So this is Math 241, Day 5, Part 1, where we will look at decimals and the different concepts of decimals, percents, and proportions. So far in all of our work in this class, we've talked about what base 10 means and the base 10 blocks. So before this video and before we got to decimals, we knew that the flat represented 100 and the long represented 10 and the unit represented 1. Well, now we're just transitioning into our decimal notation. And so now the flat represents 1 and the long represents a tenth and the unit represents 1/100th. So to represent certain decimals using the base 10 blocks and the flats, when you're looking at 57/100ths, notice that this represents your whole amount. So there's your whole, and since it equals one whole, then you've got 100 of the units, which each one represents 1/100th. So 57/100ths, I need 5 longs to represent the 5/10ths. So there's 4/10ths, 5/10ths, 1, 2, 3, 4, 5, 6, 7/100ths. So that would represent 57/100ths. 25/100ths, I just need 2 longs and 5 units to represent 25/100ths. And then 85/100ths, the 85/100ths would be represented by 1, 2, 3, 4, 5, 6, 7, 8, and 5/100ths. So 8 longs and 5 units. And then this last one, dealing with 1 and 45/100ths, you need to have the entire whole. So I need all of that to represent the 1. And then I need 45/100ths. So I need 4 longs and 5 units. So that would be a way to represent certain decimal numbers using the flat for the base 10, from the base 10 blocks. So when we think about percent, we say percent means per hundred or hundredths. So another name for that would be hundredths, or we can say per hundred. And so we're just thinking that everything is out of 100. So we take the number 3/4 as a fraction. So when we take the number 3/4, that's equivalent. So we can think equivalent fractions to 20ths, 15/20ths. We can also think scaling it all the way up to 100, and we would have 75/100ths. So these would be the same, and so we would need 7 longs, 5/100ths to represent the 10 by 10 grid. And since 3/4 is a fraction, the decimal would be 75/100ths because you're reading the fraction. And as you read the fraction correctly out of 100, you would see that the 5 is in the 100th spot. And then so percent means per 100, so we would have 75%. Same thing with 2/5. 2/5, we could look at how many times will we multiply to get to 100, and that would be 20. So 5 times 20, 2 times 20, so I'm at 40 hundredths, and the fraction is 2/5 is the same as 40 hundredths, which is the same as 40 hundredths or 4/10. And since it's 40 hundredths, we would say that the percent would be 40%. And then the grid would just mean that there's 2, 3, there's 4 flats to represent the base 10. When we're talking about decimal fractions from least to greatest, so everything has been whole numbers so far for the students. They have had their conversation with fractions, and then now taking the numbers 1 or 0 through 10, I just want to have the students look at, well, what's happening between 0 and 1? So let's look at there and let's just blow it up. So we're going to blow it up. This page, we've taken this piece, this space between 0 and 1, and we just blew it up to the and zoom in to this next figure. So the next figure is between 0 and 1. Well, that would mean that we're looking at tenths. So 0 tenths, 1/10, 5/10, and then 10/10 is the same as 1 whole. 0/10 is the same as 0. So now we've taken that as I had on the text, and now we're looking here. So this is from 0 to 1. And now I would like to say, well, let's take it from 0 to 1/10. And let's maximize that piece. And so look inside that section here, and we're going to see 1/100th. So a 1/100th. 5/100ths. All the way to 10/100ths, which is the same as 1/10. 0/100ths is the same as 0/10. So we can continue going and subdividing that, and we would get smaller and smaller, and it is called continuous data. You're always going to have intervals because you can always make the number smaller, so that you'll have an infinite number of intervals between 0 and 1. Putting numbers on the number line, so you think about ordering. So we've got 1, 2, 3, 4, 5. We've got 6 numbers to order. And so you want to think about benchmark numbers. So if you're looking at everything, I don't see 0, but I do see 1. So I've gone from 0, and let me back this up a little bit because I also see 1 and 25/100ths. So I'm going to make this 1, and this would be 1 and 25/100ths. And so I'm just kind of notating what I see here. I've got 0, I've got halfway, which would be 5/10 or 50/100ths. And then think about, well, just less than that, we've got 3/10 repeating, which would be this one. And then just below that would be 3/10. And then just smaller than that, we would have 25/100ths. So that's your thinking of how you would order your fractions. The second one, notice you've got 5 and 3/10, 6 and 0/10, 5 and 3/10, 5 and 0/10, 5 and 4/10. So we know we're going to be somewhere between 5 and we'll say 6 with a little bit of extra here. So here's 5.5, and we'll say here's 6.5. And so this 6, now the 4 right here is actually in the tenths, hundredths, thousandths, 10,000ths. So that is just a little bit more than 6. And then this one's just a little bit more than 5. Now when we look at these two, I've got 5, and so just a little under 5.5. So that would be 40,364 ten thousandths, 100 thousandths, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths represents that 4. And so that one's taken care of. And then I've got 5 and 36 hundredths, and this is 5 and 364 thousandths. So notice this one is 5, and you can actually write it as 360 thousandths. So one's going to be right here. We'll say 5 and 360 thousandths, and then the other one just a little bit beyond it. It's not drawn to scale. As you can see how we're ordering the decimals. There's some common misconceptions when you're thinking about decimals, and lots of them deal with, well, it's the larger number. So think about students in the past when you look at 3,457 compared to 285. Well, that one's obviously larger. There's more digits. It's a bigger number. Not always the case here when we're dealing with our decimals. So this one is around 6/10. This is around 7/10. The 75 hundredths is larger than the first decimal. And you only have to look at one place past the decimal, and that would be 6/10 and 7/10, and you know that that one's larger. Another misconception is just the shorter decimal. And so this is 32 hundredths, and this is 34,789 hundred thousandths. And so this one would be larger. Shorter decimal is not larger. Also think about intervals of 0, thinking that this 305 thousandths doesn't have any meaning. As opposed, if I put the 0 out here, now I've got 35 hundredths or 350 thousandths. So this one's 350 thousandths, this one's 305 thousandths. Well, that one would be greater. So there is, that 0 does have a misconception on the page over here. The longer decimal is larger. So we also have students that think anything less than 0. So this 0 to 1 idea, that if they see a decimal, 254 thousandths, they actually think that it's over here. It's less than 0, because you see this first whole number is 0, which means we don't have any whole numbers, so that means we got to be less than 1 whole. So all these numbers would be falling in between 0 and 1. Anything less than 0 is now becoming negative. So if you say 4/10 or 6/10, a lot of students will write that denominator as 1 divided by 4 because that's what they see in the decimal place. So that reciprocal thinking is incorrect. And then a lot of students just have a hard time with, well, 78 hundredths and 780 thousandths, are those the same? And a lot of students will say no, because most of them lean towards the bigger number, which is that students will struggle with that, or they won't see how things compare equivalently. The 5/10, which is 5/10, and 500 thousandths, that these are actually the same as half. So let's look at some addition with different methods. So if I say 3 and 38 hundredths and 2 and 85 hundredths, I want to think front-end estimation, so I'm going to say 3 plus 2, and I'm going to get approximately 5 as my answer. So in this case, how long did it take him to answer both problems? About 5 seconds, if we estimate. If I want to use the base 10 blocks, then I want to model 3 and 8500ths. So that's 3 flats, 8 longs, 5 ones. 2 and 8500ths would be 2 flats, 8 longs, and 5 hundredths. And I believe I wrote that down wrong. 3 and 38 hundredths should be just 3 of these, and there's 5, 6, 7, and there's 8. So got that cleared up. So if I want to use the base 10 method, then I want to think, all right, I've got 2 here, I've got 3 here, so far I've got 5. I have 1, 2, I've got 3 longs, and I've got 4, 8. And then let's look at my ones. So 1, 2, my hundredths. So 2, 4, 6, 7, 8, 9, 10, 11, 12, 13 units. So let's do some regrouping. Let's do some trading in. So these 10 here will come over here and create a new long. And then I've got 3 hundredths remaining. And then here I've got 4, 5, 6, 7, 8, 9, 10, 11, 12 of these. So I only need 10 to create a flat. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all of these are now going to make a flat. And so then that leaves me with 2/10. And then now I can look at it, I've got 3, 6, 7, 8, I've got 9. I'm sorry, I don't know why I counted that one. I'm looking at all these together, so 1, 2, 3, 4, 5, I've got 6. So I've got 6 and 23 hundredths using the base 10 blocks. So next, let's look at expanded form. Take 3 and 38 hundredths, 2 and 85 hundredths. We're just going to expand it to the 3 wholes plus 3/10 plus 8 hundredths plus 5 hundredths plus 8 hundredths plus the 2 wholes. So this is going to give us 13 hundredths, and this will give us 11/10, which would be 1 and 1/10, and 5. So the whole numbers would be 5, that would be 6, and this would be 1/10, and another 1/10 would be 2/10, and there's your 3 hundredths. So just expanding it by the place value. Next, if you look at partial sums, very much like partial sum with whole numbers. So the 8 hundredths and the 5 hundredths make 13 hundredths. The 8/10 and the 3/10 make 1 and 1/10. And the 2 and the 3 wholes make the 5 wholes. And so notice that just kind of intuitive, based on adding your place values, the decimal point follows all the way down and lines up. So you would get 6 and 23 hundredths. Fraction model would be 3 and 38 hundredths Now that's going to be the same. Notice that the 8 is in the hundredths place. So we would say 3 and 338 hundredths plus 2 and 85 hundredths. The 5 is in the hundred spot, so we would say 285 hundredths. Now, to finish that, you're still dealing with hundredths because the fractions and the least common multiple of 100. So now we have common denominators, so now we can add. So we can add the 338, 285, however we would like to do that. And so we can we would have no decimal point at that. So you'd have 623 hundredths, and 623 hundredths divided by 100, because there's your decimal point, it would be 6 and 23 hundredths. There's your fraction model. Figure out the place value of your last place value, and since it's hundredths, then we take the number 2 and 85 hundredths and make 285 hundredths, 338 hundredths, and now that we can add those together. So you're really just adding the whole numbers at that point. But then in the end, you've got to divide by 100, which causes the decimal point to move 2 to the left, because once you add these two numbers together, the decimal is to the right of the ones place. And then finally, your standard algorithm, 3 and 38 hundredths, and 2 and 85 hundredths. So 8 hundredths and 5 hundredths is 13 hundredths. 13 hundredths is 3 hundredths and 1/10. So that's why the 1/10 is above the 3/10. So that's 11. That's 12 tenths. And 12 tenths is 2 tenths and 1 whole. So the 3 and 2 is 5 plus 1 is 6. So here we've got Jacqueline ran 2 and 76 hundredths miles in 25 minutes. Marcus ran 2 and 68 hundredths in 25 minutes. You just want to know how much they run all together. So we're going to add these together. But if we're thinking front end, 2 and 76 hundredths and 2 and 68 hundredths. So we could just look at the front end there and say it's approximately 4. You could round 2 and 76 hundredths to 3, 2 and 68 hundredths to 3. So we would have a high and a low end of our estimate. With the base 10 blocks, we're going to represent 2 flats, 7 longs, 6 hundredths, and then we've got 2 and 68, 1, 2, 3, 4, 5, 6, 10, so you've got 6 longs and 8 tenths. So these 4 make your 400, make your 4. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these would all make another 100, or another 1, excuse me. And that leaves you with 3 tenths left over. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these would come over here and add to make another 10th. And then that would leave you with those 4 tenths, or 4 hundredths. So you're going to have 4 and 1, that's 5. 3 tenths and 1 tenth would be 4 tenths plus 4 hundredths, which would be 5 and 44 hundredths. So there's your base 10. Expanded form, 2 and 76 hundredths, 2 and 68 hundredths. Adding those together, so that would be 2 plus 7 tenths plus 6 hundredths, 2 plus 6 tenths plus 8 hundredths. So you add those together, you're going to get 14 hundredths. Here you're going to get 13 tenths. And here's 4. So the 4 and the 1, that makes 5 plus 3 tenths plus 14 hundredths. So these two would make 4 tenths plus the 4 hundredths plus the 5 would be your expanded form. Partial sums, we've got 2 and 76 hundredths, 2 and 68 hundredths. If I add that, I'm going to add the 14 hundredths. That's what 8 hundredths and 6 hundredths would be 14 hundredths. And then the 7 tenths and the 6 tenths will make 13 tenths. And then the 4 wholes. So you get 5 and 44 hundredths. So that would be your partial sums. Expanded or fraction form. 2 and 76 hundredths is the same as 276 hundredths. 276 hundredths. And then 2 and 68 hundredths would be 268 hundredths. Now I can take 276, 268, I can add those together, and I'm going to get 544 hundredths, which when you divide 544 hundredths by 100, you're going to get 5 and 44 hundredths. And that's your fraction model. And then last, your standard algorithm. Line up the decimal points. That's 14 hundredths, so 14 tenths for 5 and 44 hundredths.